In this video, we'll be taking the topic of fair division to the notion of organ transplants. In 1984, the U.S. Congress passed the National Organ Transplant Act and established a unified transplant network known as the Organ Procurement and Transplantation Network. The primary goal was to increase equity in organ allocation. Some tough questions immediately arise. Should an available organ go to the patient who needs it most? Should it go to the person with the greatest likelihood of a successful transplant? If both of these notions are considered, how do we do so? There are three criteria that come into place. One is waiting time. How long has a potential recipient been waiting? The second criteria is suitability. The donor and potential recipient each have 6 relevant antigens that are matched or not matched, and the likelihood of a successful transplant increases with more matches. The third criteria, we're going to label disadvantage. Each person has antibodies that rule out a certain percentage of the population as being potential donors for that person. We'll say more about this in a moment. Let's first take waiting time. A list of potential recipients was made according to how long they had been waiting for an organ. And for each potential recipient, one calculates the fraction of people at or below the spot on the list he or she occupies, and then awards that person a number of points equal to 10 times that fraction. For example, if there are 5 people on the waiting list, the first one on the list, the one who's been waiting the longest, will get 10 times 5 divided by 5, or 10 points. The person waiting second on the list will get 10 times 4 divided by 5, or 8 points. The third on the list, 10 times 3 divided by 5, or 6 points, and so on. This is how points are awarded based on the criteria of waiting time. Next, suitability. Recall that the donor and potential recipient each have 6 relevant antigens that are matched or not matched, and that the likelihood of a successful transplant increases with more matches. Here, 2 points are awarded for each antigen matched. The third criteria is disadvantage. So each person has antibodies that rule out a certain percentage of the population as being potential donors for that person. For some, only 10% are ruled out, whereas for others it may be as high as 90%. And those in this latter category, those who will not match with 90% of the population, are at a serious disadvantage compared to those who only have a mismatch with 10%. Potential recipients are going to be awarded 1 point for each 10% of the population they are sensitized against. So, for the person who is only unable to match with 10% of the population, they will get 1 point. Whereas for someone who is unable to match with 90% of the population, we'll give them 9 points. Because in the event a potential match for them comes along, we want to take into account their disadvantage in general. Here's an example. Here we have 5 potential recipients: Anna, Bobby, Carrie, Danny, and Elizabeth. And the chart tells us the number of months each of these potential recipients has been waiting, as well as the antigens matched and the percent sensitized against the population. We're going to award points as follows, starting with waiting time. For each person, they will get 10 times the fraction of people at or below them on the list. There are 5 people. Anna's been waiting the longest, so Anna will receive 10 times 5 divided by 5 points. Bobby, 10 times 4 divided by 5. Carrie, who's third on our list, 10 times 3 divided by 5. Danny, 10 times 2 divided by 5. And Elizabeth, 10 times 1 divided by 5. Cleaning those up, we see Anna gets 10 points, Bobby gets 8, Carrie 6, Danny 4, and Elizabeth 2. Note that it doesn't matter how many months each person has actually been waiting, only the order in which they appear as far as who's been waiting the longest to the most recent on the list. Let's clean up those waiting points. Next, move on to antigens matched. Remember that each potential recipient is awarded 2 points for each antigen matched. So for antigens, Anna will receive 2 times 2, or 4 points. Bobby also 4, Carrie none, Danny 6, Elizabeth 12. Again, we simply multiplied each number by 2. Now we move on to the percent sensitized, and each person receives 1 point for each 10% of the population they are sensitized against. So Anna will receive 1, Bobby 2, Carrie none, Danny 6, Elizabeth 9. You can think of this as just deleting the 0 on the end or dividing by 10. We add across the rows for total points. Anna ends with 15, Bobby 14, Carrie 6, Danny 16, and Elizabeth 23. Therefore, because Elizabeth has the highest number of points, the available kidney would go to Elizabeth. What do you think about the fairness of this procedure? Keep in mind that math can only give us a procedure. They can't encapsulate everything that goes into fairness. Before you decide how you feel about this procedure, let's discuss something interesting that happens. What if 2 kidneys happen to be available at the same time? We already saw that the one will go to Elizabeth with the highest number of points of 23, and the second kidney would go to Danny since he has the next highest number of points at 16. So if 2 kidneys become available at the exact same time, they will go to Elizabeth and Danny. Here's something interesting. Instead of them being available at the exact same time, what if they're a month apart? So the first kidney will go to Elizabeth. Suppose a month passes. Now, how will points be allocated when a new kidney becomes available? There are now 4 people on the waiting list. So our waiting points will be awarded as 10 times for Anna, 4 divided by 4, Bobby, 3 divided by 4, Carrie, 2 divided by 4, and Danny, 1 divided by 4. So Anna will have 10 points, Bobby 7.5, Carrie 5, and Danny 2.5. We'll clean that up. The antigens matched again, we multiply by 2. So Anna receives 4 points, Bobby 4, Carrie 0, and Danny 6. Percent sensitized, we divide by 10. Anna receives 1 point, Bobby 2, Carrie none, and Danny 6. Adding across rows, Anna has 15 points, Bobby 13.5, Carrie 5, and Danny 14.5. In this scenario, the kidney would now go to Anna. Compare the 2 cases. We said that if 2 kidneys became available at the same time, they would go to Elizabeth and Danny. But if they're spaced out 1 month apart, then the second kidney would no longer go to Danny, but would go to Anna. Does this change how you feel about this procedure? Maybe, maybe not. That's all for this video. Thanks, guys.